Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. In this video, I'm going to present the discussion on the construction of shear and moment diagrams using the area method. And for the theory and the concept on the construction of shear and moment diagrams, please look at first my video on the relations among the shear, the moment, and the load. Level 41. Construct the shear force and bending moment diagrams for the beam shown by the area method. Neglect the weight of the beam. Also determine the absolute maximum shear and absolute maximum moment. So here's the given figure. We will call the reaction at A as vertical reaction as AY, horizontal reaction 0, and R sub C at C. Summation moment about C equals 0, AY times 4 plus 120 times 2 times 1 minus 100 times 2 minus 120 times 2 times 3 equals 0. So AY is equal to 170 pounds. Then summation of moments about A equals 0, counterclockwise positive, R sub C times 4 minus 120 times 2 times 5 minus 100 times 2 minus 120 times 2 times 1 equals 0. So R sub C is equal to 410 pounds. So that makes it 580 pounds. The total load is also 580. So we are now ready to sketch the shear and moment diagrams. Let's put the reactions. AY 170 and R sub C is 410 pounds as shown. So first from 0 to 170 here. Then minus this loading 120 times 2, negative 240. So 170 minus 240, that's constant slope of negative 120. So remember, so negative 70 here. Then there is a load, so negative 70 minus 100, negative 170. Then between B and C, there's no loading, so it is constant at negative 170. Then there is an upward reaction. So negative 170 plus 410 is 240. Then 240 minus 120 times 2, again a straight line with negative slope 0. So that's it. So this distance is solved by similar triangles. X as to 170 equals 2 minus x as to 70. But the easier way is shear 170 divided by intensity of the load 120. 170 divided by 120 is 1.4167. Therefore, this is 0.5833 foot. So let's shade first. The area is 1/2 of 0.5833 times negative 70. The area here is 1/2 of 1.4167 times 170, so 120.42. This one 1/2 of 0.5833 times negative 70 is negative 20.42. Then negative 170 times 2, negative 340. 1/2 of 2 times 240 is 240. So we don't need that because we can easily compute for that area. So let's project moment at A is 0. That's an end support that is spin. Then we have slope which is 170 to the moment diagram to 0 shear here, so 0 slope. So connect that positive slope and horizontal slope here with a smooth curve, so it is concave downward with the value here 120.42. Then from horizontal slope to negative 70 slope, connect with a smooth curve, so it is concave downward again. 120.42 plus negative 20.42 is 100. Then we have constant slope of negative 170, so that's a straight line. 100 plus negative 170 times 2, so negative 240 here. Then plus the area here, which is 1/2 of 2 feet times 240, so positive 240. From positive 240 slope to zero slope, it looks like that. So connect with a smooth curve. So that's the moment diagram. So the absolute maximum shear based from the figure is 240 pounds, and the absolute maximum moment is also 240, although it's negative, but the absolute value is 240 pounds. And this occurs at x equals 4 feet from the left, so 4 feet. Level 42, construct the shear force and bending moment diagrams for the beam shown by the area method. Neglect the weight of the beam. Also determine the absolute maximum shear and absolute maximum moment. So here's the given figure. We have at A, AY, and AX0, and at C, R sub C. So summation moment about C equals 0, AY times 7 plus 7 times 3 times 1.5 minus 14 times 4 times 2 minus 7 times 3 times 5.5 equals 0. So AY equals 28 kilonewtons. Likewise, summation moment about A equals 0, counterclockwise positive. R sub C times 7 minus 7 times 3 times 8.5 minus 14 times 4 times 5 minus 7 times 3 times 1.5 equals 0. So R sub C is equal to 70 kilonewtons. So I believe the summation forces Y check if it is 0. So we are now ready to sketch the shear force and bending moment diagrams. Let's put the reactions. AY is 28 and R sub C is 70 kilonewtons. So for the shear diagram in kilonewtons, first we go up 28, then plus the area, which is negative 7 times 3, negative 21, so straight line, negative slope of 7, so that's a line with negative slope. So 28 plus negative 21 is 7. Then between B and C, we have slope of negative 14, so straight line again, negative 14, 7 plus the area, negative 14 times 4, which is negative 56, so negative 49 here. Then there is an upward force, so negative 49 plus 70 is 21, positive. Then 21 plus the area, negative 7 times 3, negative 21, so 0. So connect 21 and 0 with a straight line, negative 7 slope. So that's a line and it closes. This distance is shear 7, not by similar triangles anymore. So 7 divided by intensity of the load, 14, so 0.5. So that's 0.5. Let's shade. The area is 1/2 of 0.5 times 7 for this small triangle, 1.75. This is 1/2 of 3.5 times negative 49. The area is negative 85.75. The area of the trapezoid is 1/2 of 28 plus 7 times 3, 52.5. And the area of this triangle is 1/2 of 3 times 21, 31.5 kilonewton meter. So for the moment diagram, moment at A is 0, of course, that's a pin support and end support. Then we have slope which is positive 28 to positive 7, but smaller, almost flat. So concave down again, that one. So 52.5, that area. Then positive 7 slope to 0 slope, 0 shear here, horizontal. So it looks like this, but the slope here is horizontal. So 52.5 plus 1.75 is 54.25. Then from horizontal slope, 0 shear to negative 49, concave down. 54.25 plus negative 85.75 is negative 31.5. Then from 21, the slope positive to 0, concave down. So that's the moment diagram. So the absolute maximum shear from the figure is 49 kilonewtons, and the absolute maximum moment is 54.25, and it occurs at x equals 3.5 meters. Level 43. Construct the shear force and bending moment diagrams for the beam shown by the area method. Neglect the weight of the beam. Also determine the absolute maximum shear and absolute maximum moment. So here's the given figure. Let's call the reaction at B as R sub B, as shown at dy and dx is 0. So summation moment about D equals 0, clockwise positive, R sub B times 6 plus 60 times 3 minus 12 times 5 times 5.5 equals 0. 5.5 is 2.5 plus 3. Half of 5 is 2.5 plus 3. So R sub B is equal to 25 kilonewtons. Likewise, summation moment about B equals 0. dy times 6 plus 60 times 3, then minus 12 times 5 times 0.5. 0.5 because the distance of the centroid from the left is 2.5, because it's a map moment about B, and this is 2. 2.5 minus 2 is 0.5. So dy is equal to negative 25 kilonewtons. So we are now ready to plot the shear force and bending moment diagrams. Let's put the reactions 25 here and downward 25 here. So for the shear diagram in kilonewtons, so beginning with 0 shear at A, then we have negative 12 slope, which is the intensity of the load, straight line, because that's 0 degrees, so first degree here. So 0 minus 12 times 2, so negative 24, plus 25, so 1. 1 minus 12 times 3, 1 minus 36, negative 35, straight line again, negative 35 here, plus 60, 25. Then no change in loading, no change in shear, horizontal. Then minus 25, 0. So this distance is 1 shear divided by intensity of load 12, so 1 over 12. So therefore this is 3 minus 1 over 12, or 2 and 11 over 12. So let's shade the portion. So we don't need to label the areas. We'll just calculate them as we compute for the moments. So moment at A is 0, then plus this area, which is negative 1/2 of 2 times negative 24, which is negative 24. From 0 slope to negative 24 slope, concave down like that, because that's first degree, this is second degree. so negative 24. Then we have a positive area which is very small, 1/2 of 1 over 12, 1 over 24 times 1, so 1 over 24. Negative 24 plus 1 over 24, and it is from positive 1 slope to 0 at this point, very small, so concave up, concave down again, and the value here is negative 24 plus the area which is 1 over 24 in decimal, negative 23.958. Then the area of this diagram is 1/2 of 2 and 11 over 12 times negative 35, and it is from 0 shear or 0 slope to negative 35 slope. So to connect them, concave down again like that, and the value here is negative 23.958 plus 1/2 of 2 and 11 over 12 times negative 35, so negative 75. Then next is constant slope at 25, like that, and 25 times 3 is positive 75, negative 75 plus positive 75 is 0. So that's the moment diagram. Then from the figure, the absolute maximum shear is 35, and the absolute maximum moment is 75, and it occurs at x equals 5 from the figure. So that's it. Level 44, construct the shear force and bending moment diagrams for the beam shown by the area method. Neglect the weight of the beam. Also determine the absolute maximum shear and absolute maximum moment. So here is the given figure. Let's call the reaction at B as By and Bx is 0. At E, R sub E. So summation moment about E is 0, clockwise positive. So By times 6 plus 120 minus 60 times 4 minus 20 times 4 times 6 equals 0. So By is equal to 100 kilonewtons. Likewise, summation moment B equals 0, counterclockwise positive. So take note that the centroid of this rectangular loading is here at B, so the moment arm is 0, so we don't need to include this in the moment equation. So R sub E times 6 minus 120 minus 60 times 2 equals 0. So R sub E is equal to 40 kilonewtons. So that's 140. 20 times 4 is 80 plus 60 is also 140. So let's now plot the shear and moment diagrams. Let's put the reactions. By 100 and here Re 40. So beginning at A, 0 shear, then this is negative slope constant, so straight line here. The area is negative 20 times 2, so negative 40, from 0 to negative 40, straight line. Then plus 100, negative 40 plus 160. Then plus this area, which is straight line again, negative slope, negative 20. The area is negative 20 times 2, so 60 plus negative 20 times 2 is 20. Then minus 60, so negative 40 here. Then there's no change in loading, so horizontal. Then that's moment or couple, so horizontal. Then it closes because we have 40 there. So this is the shear diagram after shading. For the moment diagram, there's no need to label the area. We can easily compute the areas. Beginning with A, it's 0. Then the ordinate to the shear diagram corresponds to the slope, horizontal slope, then negative 40, like that. So to connect horizontal slope and negative 40 slope with a smooth curve, it is concave downward. and the area is 1/2 of 2 times negative 40, so it is also negative 40. This is from positive 60 slope to positive 20, so it is concave downward also, like that. Positive 20, positive 40 slope, concave downward. The area is 1/2 of 2, so 1 times quantity 60 plus 20, so 80. Negative 40 plus 80 is positive 40. Then the area of this diagram is negative 40 times 2, negative 80. Straight line, constant slope, but negative. So 40 plus negative 80 is negative 40 here. Then, because we have a clockwise couple, 120, negative 40 plus 120, so positive 80. Then plus this area, which is negative 40 times 2, negative 80, constant slope, so 0. Connect with a straight line. So that's the moment diagram. And the absolute maximum shear is 60 kilonewtons, while the absolute maximum moment is 80 kilonewtons, and it occurs at x equals 6. So that's it for this problem. Level 45, assuming the upward reaction of the ground on beam AB to be uniformly distributed. Letter A, draw the shear and bending moment diagrams, and B, determine the absolute maximum values of the shear and bending moment. So here is the given figure. So let's put the reaction of the ground, which is uniformly distributed as mentioned in the problem as shown, and we will call that WR, the intensity. So summation forces vertical equals 0, WR times 6 minus 8 times 1.5 times 2 equals 0. So times 2 because we have identical downward loading. So WR equals 4 kilonewton per meter. So we are now ready to sketch the shear force and bending moment diagram. So that's the upward uniform reaction, 4 kilonewton per meter. So therefore, in this portion, 1.5 meters from A to C, the net uniform downward load is 4, 8 minus 4, so negative 8, negative 4 kilonewton per meter. So shear diagram in kilonewtons. Beginning with 0 shear here, take note that the net downward load is 4 kilonewton per meter, so minus 4 times 1.5, that's negative 6. So 0 to negative 6. And since we have first 0 degrees of straight line here, and it is negative 6. For the next, we have straight line also, but positive slope of 4. So constant slope, and the area is 4 times 3, which is 12. Negative 6 plus 12 is positive 6. Then the net downward load is 4 kilonewton per meter times 1.5. So negative 6, 6 plus negative 6, 0. And the slope is constant, but negative 0. So that means by symmetry, this is 1.5, half of 3. So that's the shear diagram. For the moment diagram, beginning with 0 moment at A, so this is from horizontal slope to negative 6 slope. So we connect them with a concave downward curve like that. And the area is 1/2 of 1.5 times negative 6. That would be negative 4.5, concave down. Then from here to here, the slope is horizontal. The area is negative 4.5 again. Negative 1/2 of 1.5 times negative 6, negative 4.5. Negative, then horizontal slope here. So concave up slope, or negative decreasing slope. Like that. Why? Because the slope here is negative 6 and the slope here is horizontal. So negative 4.5 plus negative 4.5 area is negative 9. Then here we have 0 slope, horizontal, to positive 6 slope. So it is concave up like that to connect the two curve. Negative 9 plus 1 half of 1.5 times 6, 4.5. So negative 4.5 here. And from the last part, we have positive 6 slope to horizontal slope. So we connect them with a smooth curve, and it is concave downward. So that makes it 0 because this is negative 4.5 plus the area of this triangle, which is 4.5 also. That makes it 0. So that's the moment diagram. And the absolute Mach value of the shear is 6, while the absolute value of the moment is 9, and it occurs at x equals 3 meters. So that's it for this video.